Example 2, using sine, cosine, or tangent. Find the unknown angle D. Okay, so it's giving us the perspective. It tells us we're going to look for, we're going to reference D moving forward. So, this is different than the previous examples in that we're not finding a missing side. Look, there's already two sides given. I've told you before, I'm going to always give you at least two pieces of information in order for you to find the third. And so I've already got the two sides, meaning the angle needs to be found, but also it just says find the angle. So let's actually try that right now. So that is my perspective, and I need to start labeling things. So across from the 90 is the hypotenuse. So that's the hypotenuse. And I'm going to look here, opposite. I'll label that as opposite. And that just leaves the adjacent. So adjacent. And I'm going to choose the hypotenuse because that information is given. And also 15 is given. So I've gotten hypotenuse and adjacent, both of those. But which formula is that? So A and H. A and H would be cosine, so ka. So my formula is going to be cosine of an angle equals A adjacent over hypotenuse. Okay. And what is my angle? Cos of an angle. I don't have the angle. That's right. That's the whole point. I need to find the angle. So that's D equals adjacent, which is 15, over hypotenuse, which is 25. Okay. So cosine of D equals 15 over 25. I guess I'm going to need to find out what that is. I know that those can both be reduced by 5, right? I can simplify those. I can divide them both by 5, which would give me 15 divided by 5 is 3, and 25 divided by 5 is 5. Now 3 over 5 is actually the same thing, and it's helpful because 3 over 5 is the same thing as 6 over 10, which is 0.6. So you can, I don't know how you need to figure this out somehow, which is 0.6. I mean, I guess you could, if you wanted to, try to do 25 into 15 and realize that it can't go into there, so you have to go to 150. And how many times does 25 go in there? 6 times. And you're going to get 0. So maybe you can do some division that way, but if you just reduce the fraction, and I'll try to do that for you, try to make these things doable. If you divide by 5, you can get 3 over 5, which is the same thing as doubled 6 over 10, which is the same thing as 0.6. So I'll write that down here actually, 0.6. Now, when you're trying to find the angle, you're trying to find the degree. Oh, what are we doing? Cosine? Cosine. When you're trying to find the degree, you're going to have to use a table and work backwards. So I am looking under the cosine here for 0.6. Okay, so that's what I'm trying to find. 0.8, 0.8, 0.7, 0.7. Okay, starting on the other side again. Okay, 0.6. Oh, okay, that's really close to here. And what is that angle? 53. Like sometimes it's between 52 and 53. In this case, yeah, it is between 52 and 53, but it's so much closer to 53. So I'm just going to say it's 53. We're just estimating here. So I would say that D is equal to, using the table, 53 degrees. Right? So that's from the table. Now, if you had to actually work backwards, you have to do the cosine inverse. So D is equal to, because you would end up doing, remember, cos negative 1 of both of these, and those would cancel out. So D equals cosine of negative 1, 0.6. Actually, maybe I forgot I can now do this with my pen, so I can probably just move this here. I'll show you what I mean, even though I said I would never do this again. So you can do cos, whatever you do to one side, you have to do the other. So you have to do cos negative 1 of both sides. And of course that can cancel out. So you're just left with d equals cos negative 1 of 0.6. Now, that's only helpful if you're ever using a calculator. When you're using a table, it's really obvious. You're trying to find d. D is the angle. And so you're looking on the other part of the table to find the angle. But for a calculator, you're not looking at a table. The answers aren't there. You're just picking one out. You actually have to know what to press. So that's where this cos negative 1 stuff comes in. And so if you're ever trying to find the angle, you have to do cos inverse of 0.6. So let's do 0.6 and cos inverse, cos negative 1, and 53.13. So 53.13 degrees. And of course that's also approximate, like everything else here. And that was using a calculator. 53.130. Okay, so that is how you do this with a table and with a calculator. All right, so here we are. We're trying to find angle D, which is right there. That is going to be our perspective. Now, across from the hypotenuse, or from the 90 degrees, is the hypotenuse. And then from here, go opposite. So this will be the opposite. And therefore, this must be the adjacent. All right, so which formula to use? So I have 14, so I'll use that. And I have 42, so I'll use that. So O and A. Okay, sorry about that. Let's see what I was doing here. I mean, there's like a 15-minute pause. So I have O and I have A, opposite, adjacent. So that's O and A. So that would be TOA. So my formula would be tan of some angle equals O, opposite, over A, adjacent. Okay, so tan of the angle. What is the angle? Of course, it's D. I forgot. Opposite, is that the one that was, it was 14 over adjacent was 42. Now this looks strange, 14 over 42. However, I do know that 14 over 42 can be reduced. So just like that one that was 15 over 25, sometimes it's helpful to reduce these things. So I can reduce them both by 7. So I would get 2 over 20, 7, 6. Oh, that's just 1/3. So tan of D, 2 over 6, those can both be divided by 2, which is 1 over 3. And 1 over 3, you should know, is 0.33 repeated. Okay, so now the nice thing about the chart is you're trying to find the angle, so we can just work backwards. We can look at the body of this thing and look for 0.333 anywhere for tangent. And so 0.3, so this is tan, 0.333, okay. So it's right here and here. So it looks like it's actually pretty close, halfway between 18 and 19. So I might say that's 18.5. If we had to get a little bit closer, yeah, then that's really, really close. Without doing some math, it would be too complicated. So I'm going to say right away, okay, well, the degree is 18.5 degrees. And so that's what's so nice about the table, is I can just look for this in the body of the chart, and then just find the degree that matches it. Now, if we were to use a calculator, what do you put in? Do you put in 0.33? Do you put in tan? And so I know I said I would never do this again, and I keep doing this. But if you actually wanted to do this with a calculator, you need to know the algebra behind it. So you have to do tan negative 1. That's the only way to get rid of tan. That's the only thing that cancels it out, leaving just the D. And of course, you got to do it to the other side. Tan of negative 1 of 0.33 repeated. So that's what I need to do. I need to do tan negative 1, 0.3333. So I can clear this off, go 0.33333333, and there's the tan -1 button, 18.43. So 18.435 degrees. So that was with the table, which I think is a lot easier, and this is the calculator, which you then have to know the algebra behind it. Okay. Now I think I have one more here, but I'm just going to zoom out in case you need to pause it and take a look at anything here. And maybe I'll just zoom in. So all of that is in one. And let's take a look here at the last one. Okay, now it did say find D again, so there's D. Okay, so across from this 90, that's my hypotenuse, so that's easy enough. And then D is going up. I'll go up here to opposite, so that would be up there. That's opposite, so this means this is adjacent. So I've given information, I have information about opposite, and I have information about the hypotenuse. O and H. O and H. That is sine. So that formula is sine of some angle equals O, opposite, over H, hypotenuse. Now the angle I don't know, that's the whole point, it's D. I'm trying to find this unknown angle, but I do know the opposite. The opposite is 15, and the hypotenuse is 30. And so sine of D, 15 over 30, that's just a half. Or you can have a 0.5. So again, with the chart, and if you're looking at sine, you're looking for 0.5. That's pretty straightforward. Let's see here. Sine's this column, and 0.5 is right there. Oh, it's exactly 0.5. I don't have the round, it's just 30. So my D is 30 degrees. Now, that's using the table. If you wanted to do this, what do you punch in your calculator? Well, you're going to have to punch in sine inverse of 0.5. So you'd have to sine inverse both sides. Sine of D and 0.5. So those can cancel. So you have D equals sine inverse of 0.5, which you go into the calculator, 0.5, hit the sine inverse, 30. And that was using a calculator. So there's that. So I realize this is the cosine tangent section, but it's good just to keep in mind that the formulas can be anything. On a test, I'm not going to say, oh, here's the sine section, just fill out these couple questions. I'm going to have them all in a big section, and your job will be to determine whether it's sine, cosine, or tangent and use the appropriate formula. So that's everything, and I still think we have maybe another chapter to go. I can't remember.